Sweet. All right, there we go. So now we're recording it. This is an overview of what we're dealing with in this first module. If you see it called a lesson anywhere, synonymous, the same thing. In this first module, I'm dealing primarily with a refresh, make sure we're all on the same page when it comes to the basics of programming and putting them in the context of Python. Now, if you haven't dealt with Python, if you haven't been in programming for a while, I've had people get into C# class, haven't programmed in 9 years. Whole lot's changed in 9 years. I'm going to post links in another page in this first module, and I'll put a link on here. So I've got some to do in here, and it says read the first chapter. I've got more going on in here than that in that first module. So in the first module, not only do I want you to read the first chapter in the book in MindTap, that'll prep you for this. If you're not fresh in Python, I just revamped my COP3530 class last semester. Totally using a textbook that's free. Everything about the course, all you pay is tuition and parking fees and an online fee, and that's it. Using Jupyter Notebooks as the IDE. Jupyter Notebooks is, you can run Python in it, you can run C# in it. It's a way for us to share what we're doing. It's the best way for it. So, show an example in here. Hang on, let me add this. Add in my algorithms page link. Enter course link. All right, so that's added in here now. If I go in here, we'll talk it a little bit later. I'll talk about algorithms, what algorithms are, why we use them. This one page is for more than just this module. There's stuff in here that'll span out over probably 4 or 5 modules as I touch on these things. What I wanted to expose you to is this. If I open this file up, this is what's called a Jupyter Notebook. And it's housed, it lives in Google Colab. So we got Google Cloud, Gmail, tons of Google products. Do you have to pay for them? Depends on what you want to do. There's only been one time I've paid for anything Google, and that's in Colab, and that's when I was trying to run that thing that took 14 hours. I said, yeah, no, let me add a GPU on top of this so I can get a little more processing power. Next day I ordered a new box online because I wasn't going to rely on them for stuff that's that bulky. For anything we're going to do or deal with in here, we can do it right in here, and it's free. So I've got a ton of notebooks. Give you access to all the notebooks that I did for COP1000 that starts out with algorithms, data types, right on down the line. You can download that and save it to your own Google Cloud account. So you would just go in from this link. You can go in, click File, save a copy on GitHub, or you can save a copy in Drive. Easy peasy. Once you got your copy, you can do whatever you want to with it. At some point, The projects are probably going to be in Colab. To where I'll give you a notebook like this one and say, go through task 1, complete this. Go through task 2, complete this. I'll show you an example of, let's see. It's not connected to my cloud right now. We'll take a break. When we take a break, I'll connect to it and I'll be able to show you. But essentially, you'll have, here's clear instructions, and then here's a coding cell. Write your code in there to do whatever you've got to do. Up here in the top, it says share. Click it, make it shareable. Grab the link, you shoot me the link, I can go in and see exactly everything you've done. You can take a snapshot in time by coming over, doing file, print as a PDF. I'm not going to do it. And that'll tell me, here's what it looked like at that one point in time. Because as soon as you save that PDF, you still have the ability to go in and modify this damn thing. So I want to see what it looked like at the point in time when it was submitted. When you grab a PDF of these things, we'll talk about it later. But just make sure everything that's in it's been run to where I can see everything that's there. As opposed to, here's a snapshot of your code and it hadn't been executed and I don't even know if it runs. There's times folks will submit code that, you know, I'll have bonus points in and they'll do half of it. There was enough points there, they're happy. I don't have to deal with the rest of it. And it ran-ish. So I get it. It's return on investment. So we'll use this stuff. If you want to go watch these once you got the other stuff done, tons of videos in here relative to algorithms and algorithmic notation. All right. Now, that said, I'd love to be able to get up to this top menu. There we go. Okay. We've got a start here menu. Like I said, the only thing that you've got right now is module 1. Module 2 won't open up probably till mid next week. And that's because I'm still defining what it is we're going to do work-wise in there. It's not about the content, it's about the work. I don't want to have you wasting your time on mind tap exercises that aren't effective when it comes to you learning. The book's a solid book. I like the book. I've used the book before. The labs, meh. That's the best way to word it. Some of them are just meh. The way they had it set up before, there may be 8, 9 labs in a module. Go do the first 2, and then do 7 and 8. The sad part is, they were all sequential, and the code from this one was used for the next one, was used for the next one, was used for the next one. So when you got to 7, they're like, all right, use the info from the last. I didn't do them. How can you do 7 when you weren't required to do the other ones? And just didn't make sense. So I'm gonna have whatever I have you do is gonna be something that I'm not wasting your time. It's not doing it. How many of y'all know about my had a bad day policy? Well, how's it go?
That will drop some of the lowest scores.
I drop a whole bunch of lowest scores because, you know, I look at it like, you know when the due dates are. If I click over in the calendar, at this point, the only things that are really due are that first module, which they're probably not due till, I think, I'll see it in here, 22nd. Week and a half. She's got a week and a half for 10 exercises that, like I said, a couple hours. That's about all it's probably going to take you. Won't take you long to read the textbook. But beyond that, it's exploring and shoring up, because going through these things is going to give you an idea of where deficiencies may lie. The whole reason we've got to have the strength here and the reason I added into these. So we're going to deal with data structures. You dealt with data types. Not a ton of them though, right? What data types you dealt with? And I'll tell you, you tell me a type and I'll tell you if it's in Python.
Float.
Yep. One of the most commonly used data types, float, in Python. Gonna be an integer. What was the one I told you didn't exist and one that does exist that's kind of like it? All right, so arrays don't formally exist in Python, but I like to word it in a way like, I know a guy. What's that mean when somebody says, I don't, but I know a guy? You know what I'm saying with that? Python doesn't have an array, but, all right. So in programming, what's a library? Let's back it up then. In this college, what's a library? Place for you to go. It's not just books. Source of knowledge, a source of resources that will help you get something done. May enlighten you. I may use the word ignorant from time to time. And I said, well, I plead ignorance. And people will say, that's so derogatory. No, it's not. I'm just being honest. Ignorance is the lack of specific knowledge. Not the lack of any knowledge, lack of specific knowledge. Man, I didn't know there was a meeting today. I was ignorant to the fact that there was a meeting today. That's all it means. So there's things that I need, I'll go get them. I can go get videos, I can go check out a computer, I can get books. So in programming, there are certain things that are built into the program. But then, man, I need a little bit extra. Well, depending on the language, how we word it, import a library, somebody else has created some code. Let me go pull that in and do what I need to do. It's more than just classes of code. So if we take another step back and think back to object-oriented programming. What's an object? It can be tough to describe. Is this an object? Yeah. Objects have traditionally two things that are associated with them. Well, aside from a name, they need a name so we can refer to them. But an object has attributes, and functionality. Attributes. 5 super grains, that's an attribute. 2 per pack, attribute. It's got functionality. Give me some energy, give me some fiber. So there's things that it can do. The company makes different ones, but about the same. So I just ate the blueberry one before class. On break, I'll have the almond butter one. Cut from the same template, if you will. This came from the same class. Just tweaked a little bit different to make this one unique from that. They may have all the attributes the exact same, with the exception of name. Or it could be name and one other one. Whatever we want it to be to set it apart from the other. Could be exact duplicates. We don't want to do that because we need to refer to them as unique entities. They may be stored in separate places in memory, but I need to be able to differentiate one from the other. So, this object-oriented programming will create instances of these objects. Now, when you think about data types are classes of code, and we just create an instance of it. So if you declare an integer, that's an instance of the integer class. It's an integer object. But we never really call them that. We just, well, that's a data type. We'll have integers. We'll have, hang on. Let me see if I can log in. Yes, I'm in. I don't know if that's going to let me sign in on here. Got to work around. I got to work around. Come on. Bear with me. I just want to get to my notebooks. And I got them. I said I did it different. That's different, isn't it? Let's go to data types. And let's come in here. All right. So Python itself, basic data types. Python itself uses what programming language to do what it does. It literally uses an existing language that you've dealt with in a way to do everything it does. So it's not just lightweight, but it's kind of cheeky because there's things that it does that are not original. It reaches over and grabs another language to do what it does. It's founded on a lot of C. So it uses C programming to do what it's doing because C's already in everything just about that we deal with. So it just reuses it. We're not lazy, we're programmers. It already exists, just reuse it. All right. So things that you already know. You know numerics, integer, float. You haven't dealt with complex. Boolean, true or false. set. That's one of the things we're gonna cover. Mapping, that's a dictionary. One of the things we're gonna cover. Sequence. Anybody dealt with a string? Right? It's basic. How about a list? In a roundabout way, if you dealt with an array, the difference between an array and a list, and you can call it a tuple, a tuple, call it whatever you want. 6 of one, half a dozen another. Start out. A string is an array. Technically, it is an array of sorts, or it's a list of characters. In this, technically, it is a list of characters. You can access them by their indices. So if you said string, whatever the name of the string was, you could have a string literal constant, 4 letters, N-A-M-E, in quotes, N-A-M-E, in quotes, followed by square braces with a number 0 in it. What's that mean?
You're pulling
the first index of whatever came in front. What came in front? That string literal constant. And that's all it is. We're jumping to that index. So it's kind of like an array. A list differs from an array in that a list can have damn near any data type in those indices. Whatever you want. You want a dictionary in index 0? You want a list in index 1? You want an integer in index 2? I mean, it can be that convoluted. So that's the difference between the lists, because in an array, how many data types can you have? Just one. They're all the same. Think about the complexity or the problems that could come up when you're dealing with a list or an array. If you're dealing with an array, treat everything that's in there the same. If you're dealing with a list, can you treat everything that's in there the same? It gets ugly. You got to treat everything real generically, not assume anything is a certain way. Now, the list, you can change what's in there. What's in index 1? Let me overwrite it and put this in there. Oh. A tuple or a tuple, however you want to say it, is like a list, but you can't change what's there. The things that are written in that structure, in that data type, it's almost like a constant. You can't go in and say, I'm going to change this index. No. You go rewrite the whole thing, but you can't change just one. A string, you can. A list, you can. So, remember I said, list, you put anything you want in there. An array, you can. A list only has a limited amount of functionality. Now in C#, there's things I'd rather do with a list than an array. There's functionality associated with a list that makes certain tasks easier. Maybe I'm more comfortable with them. No. I can, what do we call it when we change from one data type to another? Casting or typecasting. A lot of times we'd have to parse whatever it is to see. What's parsing? So let's say there's a topic that you weren't sure about, and you got your book. And you want to find out about that topic. How do you find that topic? Well, you could scan the whole damn thing, or let me go back to the back, and it's by letter. For me to find that exact word, I have to visibly scan from one point to another. That's parsing. I'm working my way from here to there, item by item. Is that it? No. Is that it? No. Is that it? No. Is that it? No. That's all we're doing. If we're parsing a string that was input that we acquired, and we're going to convert that to a float, integer, whatever. Let me go look through there, see what's there, and then, oh, wait a minute, you can't. This ain't a float. TW0, no, we can't convert that into a float, or we can't typecast that. So, when it comes to an array, right, we've got a library that we can use called NumPy. Pi standing for Python, and num essentially meaning a library for all things numeric. So I can go into NumPy and I can get some things in NumPy. There's a data type that's dtype. If I want to find out what a data type is, if I'm using that class, there's the function built into it that I can use to find out what data type is this variable. How important is that function?
It's pretty important.
I love it. Because if I'm looking at somebody else's code, I don't want to have to go scan up and go find out, oh, they didn't define everything in one place. What is this? What data type is it? So I can find out how I'm using it or what's going on. Sometimes I forget the data type something was when I brought it in. I imported it, I don't know. Let me go run a line of code in here and run type on it. Print type. That's why I love these notebooks. Put a comment in, declare a variable, and initialize it with a value. What's different about that statement from C#? No semicolon. You don't have to formally terminate the statements. And that's all a semicolon does. It's a formal termination of the end of that line of code or that statement. Now, I don't like using the term line of code because sometimes it carries over, and we can do that with certain characters or indentation. Have one, what we would call a statement that carries down maybe 5-6 lines of code for that one statement. Because I don't want my code going, man, I got a slider over here just so I can get all the way over to the end of that line of code. So with this notebook, comment, I declare the variable and initialize it. And now here I say I want to print to find out what that data type is, and there it tells me. It's an instance of the class integer. All right. And all I would need to do to run that or execute it. Really? Oh, I'm scared. I'll get back in there. Come on. Oh, that's why. Sweet. I'll connect to their server. See, it's connecting. It'll connect to their server. It literally runs everything on their processor. Anything I want to do, I'm not beating my computer up. So I can do this on my phone, I can do this on a tablet, I can do it on Mac, I can do it on PC, do it on whatever. It's one of the things that I like about this, that I go do it that way. All right. So with that, we can go find out what data types things are. We've got float and Python. We don't have double. We don't have a long. We don't have a decimal. We've got a string. So we have that. Boolean, true or false. We don't necessarily deal with bits, bytes, a word, or binary number. That's too low level for the language itself. On this one, where I say answer equals true, what data type am I using there? It's Boolean. It's either true or false. Does capitalization matter?
Yes.
Easiest way to find out? Play with these things. It underlined it. I was like, wait a minute. There's no go. Print type for answer. Bool. Do it wrong. Throw me an error. And then I come down here, it says name true is not defined. Easy to debug with this. In Sweet. Now here's an example of what you may see as a graded notebook, similar to something like this. There's a task, enter your code. Now it won't be something this damn simple at the level you're at, but structurally, so it is. Here's how many points are associated with whatever you gotta do. Write your code and run it. Very objective. Should be no confusion about it. If it says, what's the output, what are the expectations, prompted them for a name. It'll display the message to the user that is not a combination, or that is a combination of the constant that you declared and what they gave you. So as long as the constant's there and what they gave you met. I don't play games with it. I'm not, well, you didn't do it the way I wanted you to do it. You can go write that however you want, as long as the constant's there and the input's there. And I had, the last semester, I had some creative stuff submitted on that. And I get, have fun with whatever you're doing. There'll be a variety of submissions on anything that we do, because a lot of people are, let me just do what he told me to do. I just want to get in and out. We're good. Somebody else may be, I want to play with this. I want to try and kick this up a notch. And there will be extra points and whatever. And how it said, 112 points out of 100. I had one that was 150 points out of 100. But the extra 50 points, they're not painful, but it's just one of those things. Here, kick it up a notch. Go find this. I may have mentioned it, and I didn't show you how to do it. And this is kind of like prodding. Go see where this is. Go find the resources that you'll need to do what you got to do. So, open up something later. Look at 7. All right. I'll plug in videos to where you can go run it and it'll drop the YouTube video in there for you. And when I share these links, you'll have access to all these. No, that was just bringing a library. This one brings the library again and imports NumPy. Now, everybody's seen that before, something like that. Import NumPy as NP. So the import statement, there's a library that exists. I don't want to go rewrite it or recreate it. Somebody came up with it. It works. There's a whole lot of functionality in there that I like. And there are, in Python, every year, more libraries, more added to libraries to do work for you. So facial recognition. There's libraries for facial recognition. As long as you know how to use the classes that exist in there and the functionality associated with those classes, import the library, tie to these images, scan it, identify this, and it's sweet, the way it works. So people are steadily adding to what's available to you. So this one we imported NumPy as NP, it's an alias. If I import a library, there's two ways I can deal with the things in it. Implicitly or explicitly. Now, the whole reason I do the NP, let's say you write a library. You've been working on it for 3 years. You've got all these functions. And you've created a function called 3530. He's got a library. And in his library, there's a function called 3530. And I call or invoke the 3530 function without specifying whose library I'm coming off of. The program's gonna be, it may get his, may get yours, we don't know. So we need to be explicit about these things. When it comes to Python, there was a previous, it goes through iterations. There's Python 2. We'll call it 2.x. The versions we're in now are 3.x. I think we're in 3.7, 3.8, 3.9, somewhere in there. Pull the latest, I think we're in 3.9 or, look. In these notebooks, there's new stuff in there called Lambda, and there's a couple other things that are brand new to Python, the latest version. If I use something that's in the latest version, and I don't have the latest version, it ain't gonna run. They switched from 2.x up to 3.x, and it was a significant jump. Because in 2.x, there was a lot of implicit things that took place. A whole lot of implicit things that took place. Print. I didn't have to have parentheses. I didn't have to treat it like a function. There was a whole lot of what I call, don't worry, I got you, I know what you mean. And at some point, they said, look, you're all being just too ambiguous about this. We need to be a little more formal and do things a lot like C++ and C# and Java. They're not implicit like that, so let's quit being a second-class programming language. So in 3.x, the iterations of 3, it's more explicit, a little more formal. There's more functionality in the later versions. We can go through, create a list, I created in this one cell, called it LST so you had an idea of what it was. The square braces tell me that's a list. We'll deal with a dictionary, and I've already got notebooks for dictionaries and sets in there. So I've already got some notebooks for things that we'll deal with in here. When I came down to this one, I took that list. And that list could have had a variety of different things in it. And in this one statement, I created a vector. And you'll see the terms vector, matrix, a couple others that we may come up with, but you'll see vector and matrix to describe an array of 1 dimension or an array of 2 dimension. In this one, I passed that data type of list over to np.array. So the NumPy library has a class in it for an array. Python doesn't, but NumPy does. NumPy used C code to create an array data type. So now we've got one. So for years, until somebody created that library, NumPy, we didn't have an array. And I taught Python Intro to Programming, COP3530, for years using MindTap, and it said Python array. And I'm like, Python don't have an array. And then Python came out with an array when it found a guy. I know a guy, NumPy. Now we got an array. There's a whole lot of stuff like that that Python in and of itself is light and tight and efficient. But it's not limited. We can add stuff in there. Run a type on it. It's a vector. It'll tell us that it's a NumPy ND array. And then I just printed out vector created from a list, print the vector. And when I print it, it looks the same. It's in square braces. One of the things, if you take the time to go through these notebooks, scan through them, or watch the videos that I've got in them, I'm going to go plug, I think the first 5 of them I don't have videos in there. As a refresh, whatever you want to call it. You don't have to run far through them. If you went through the first 2 or 3, that's a solid refresh for the first couple of weeks. There's stuff that I deal with on the tail end of COP1000 that we cover in this class. Like I said, sets. We'll deal with that in here. Dictionaries. And conceptually, easy peasy. What's a dictionary? So if we think about it as a structure, that'd be the first data structure we're gonna deal with. So a dictionary, if we think about it as what we're used to, it's a book. This ain't a dictionary, but it's got a glossary in the back, right? Similar. What separates the glossary apart from the dictionary, if I go to the glossary, one word, one meaning. If I go to a dictionary, one word, how many meanings? As many as you want. As many as you want. So that's when we're dealing with the structure of a dictionary, there will be that single, I'm going to use the word for what it is, but we'll say that word is associated with multiple values. Simple, easy peasy, no stress. Understanding the structures, how they work, then we can go figure out how to navigate them. So what are we, an hour in? How long do we go? 2:45. All right. We'll take 2 breaks. We'll take a little break now and then another short one. And come back. That'll break this up into 3 videos.